Hello everyone, welcome back to my channel. Today we are going to see some rectifier sockets and their simulation in piecewise software. So the PN junction diode that is used in a rectifier socket because it allow only current to flow in one direction and there is no current or a very small current, appreciable current that flow in the opposite direction. So diode acts as a switch, so that is useful for conversion of AC into DC. So there are three possible circuits, that the diode can be used to convert AC into DC. So one is called half wave, second is full wave, and the third is rectifier. So you can see this is the half wave rectifier circuit where in our case we are having 230 volt and 50 hertz AC mains. So it should be converted into a smaller AC because we cannot provide larger AC or as it is AC to this particular diode. So we are going to provide a smaller AC. So smaller AC voltage like this transformer is a step down transformer. So it will convert the 230 volt AC into a smaller AC volt like 9 volt AC or 12 volt AC and so on. So this smaller AC is fed to this diode. So this diode as like the AC having alternating current, so it is having a positive cycle as well it is having a negative cycle. So diode will flow only for this positive cycle and it will not flow for this negative cycle. So that's why we are converting uh, this particular AC into a DC. So that DC will be pulsating DC. So that will be nothing but it is having a DC with AC, and then using a filter we can remove this AC component that is available at the output. So this is actually the waveform that will be available. So this is the input waveform available at the diode's input terminal, and this will be the voltage and this will be the current that will be available at the output side. So this is the output diagrams and this is the input diagram. So you can see only the positive cycle that is available here due to diode D1. The negative cycle is not available because diode flow only for the positive half cycle. So you can see here again there is a positive half cycle due to this, and again there is a positive half cycle due to diode D1. So this is a pulsating DC. So we can use some kind of a filter circuit, so that if we use capacitor as a filter, you can see here, so the capacitor will charge at this point and it will be discharged very slowly. Again it will charge, again it will be discharged very slowly, again it will be charged. So we'll have a constant DC at the output when we use a filter circuit. So let's look in the PSpice software how the simulation of this circuit can be. To draw half wave rectifier in the PSpice software, what we need to go into draw, get new part. We need a V sign for creating the alternating current. So I am placing it in here. Then in case of this we need transformer. So I am going to use uh, this a linear transformer type. So I am going to explain how it is to be done. So I am going to place over here. Then for that we need inductor. So I am going to use inductors mutual inductance concept to create a transformer. So I am needing two inductors at a time now to create a transformer. Then we need a resistor. So resistor will be there to prevent this inductor to goes into a loop. This will be the resistor that we required. Next resistor for the load. Then we need a diode. So we can take a diode which having a name model. We cannot take this D only, it is not having a model, so it will show some error. I'm going to place over here, and then what we need ground. So in case of practical circuit we have AC ground, but in case of this circuit we need to have the ground earth concept. So I'm going to put, so we require two grounds actually, so I'm putting two grounds in here, one for the input side and one for the output side. Okay, so here what we can do, we can place V sign in here. Resistance R is needed to prevent the inductor to goes into the loop. here is an inductor R. I am going to rotate it. So we are going to rotate it like this. This is the way we can connect it. This inductor we needed to form a transformer. So I am going to rotate it again. So this is the transformer now. The ground terminal is required at this part as well as at this part. Resistance R is needed at a load because we have to see the resistance, see the output at the resistance. Okay, so this is done. We need k linear map going to place over here to fit to page. Okay, so control W to join all these things together. I'm joining V sign with the resistance R1, inductor L1 to ground, again this V signs negative to ground. Then this mutual inductance concept connected this L2 to diode D1's anode. This is connected to resistance R2, again to the ground. This L2 is again connected to the ground. So how to make this as a transformer? So we have to click on this K. We have to name the L1 to be as L1 actually. Save attribute. I recommend to see this in HD so that you will able to see the smaller font size what I am typing. So L2, saying OK. So this is done. This is a transformer now because it is connected, the inductor to be connected like a mutual inductance concept. Okay, so what we need to make it step down. So I am taking it to be as 100 Henry and taking it to be as 10. Okay, so this is done. So what we need to see the voltage, means the diagram at input side as well as at output side at the load side. So we need to place two markers. Then we need to give V signs parameter. So DC parameter is supposed to be 0. Save attribute AC, but we need AC to be 230 volt. Offset be very small like 0.00001. V amplitude, VAC, these both are same, 230 volts suppose. Frequency is 50 hertz, so it will take automatically 50 hertz. Okay, so done. Then analysis, I have to save it first. File, save. I'm going to make again a folder. That folder will be named as half wave rectifier. So save it. Then analysis, electrical rule check. You can see the file, view messages. There are no error, no warning. Still at simulation point of view, they may show some error setup. So now in this case, we are going for the transient setup as we are going to vary the voltage or actually the frequency. So we have to see in between 0 to 100 milliseconds. Okay, 0 to 100 milliseconds. Okay, I'm unchecking the bias point. Okay, close, analysis, simulate. At the simulation, you can see that the output voltage is actually very large, and the voltage across the diode that is very small. That's why we are getting the DC version of it. So you can see here for the positive cycle we are getting the positive waveform, and the negative cycle we are getting the negative waveform. So we can check it as like this. This was at the very input side, so I can, if take at this side, you can see this is again simulate. You can see here now, look at here. So this L2 is nothing but the alternating current available at the second inductor, or we can say the secondary of the transformer. You are going to see the waveform is like positive going, negative going, positive going, negative going, and it is up to 50 volt. I think this is the limit 100 volt. This is up to 50 volt. So we have reduced that using the step down transformer. Now the red indicate the half wave rectification. The half wave is rectified. at the next half cycle, means negative half cycle, it remains like 0. Then for the again the positive half cycle, red cycle indicate that it is in the positive direction, means as cycle is appear as it is, the negative cycle is clipped, means we can say it is rectified actually, and we are getting a pulsating DC. So how to remove the pulsating DC? So I have said that we are going to use a filter in here. So how to use a filter in here? So we have to go for the capacitor. So I am going to take the capacitor, I am going to rotate it, I'm going to place over here. So control W to take the capacitor. So value of that capacitor is again an important part. I'm going to put it to be as 100 microfarad suppose, and okay. So how I am taking from this? So this is the dictionary where the previous things that I have taken, that will be available in here. We can see by shortcut you can take the component if we needed it again. So I have taken C from that, or else I have to go in the draw menu, get new part, and then I have to press part name, type C, and then I have to take the C from. Okay, so this is the value of the capacitor. So we'll again fit to page analysis and similar. So you can see now the voltage. I've said that uh, the very first cycle is very having very low value actually, and the very next cycle it will have a value that is from 0 to 50. So the capacitor will charge, it will discharge very slowly, it will charge, it will discharge very slowly, it will charge, it will discharge very slowly, and so on. So from 60 millisecond, or we can say from 40 millisecond onward, you will see that the voltage is in between like 40 to 50. It is varying between 40 to 50. If we take the very small voltage of the filter, you can see that it is charged for this positive part, it is discharged like this, it is charged, it is discharged like this, and so on. So for that purpose we need to understand the value of this capacitor to be not very large and not very small. I am sticked with the 100 microfarad capacitor. I'm going to simulate it, and then I'm going to get the graph like this. So this is the exact, what we can say, the rectifier. So this is not a good rectifier because it actually rectify only the half cycle. So if we have a full wave rectifier, it will rectify the both cycle, half wave as well as full wave, then we'll get the actual AC to DC conversion without fluctuation. Here we are seeing some fluctuation.